Find the focal length to a distant object.
Create a lens.
Yes. Okay. So we don't have a lens holder, but we do have these little...
Two lenses. We have a thick lens and a thin lens.
Ah, I see.
So here's the thick one.
Okay.
Here's the thin one.
All right.
Oh, yeah, okay, yeah, you can see.
So I think I'm holding the thin one.
Yeah.
Yeah.
Here's a thick one. I don't know if you can share these around.
Sure. Oh, there's a thick one. Can I try that?
There's a thick one. I like they're all different. Oh, wait, that looks like two.
Yeah, that one's got...
That's a double. It's already been put together.
Yeah. There we go. No.
Trying to get out.
No.
And then... Oh, there's our light source. And here's our screen. You should be able to see on either side.
Where did you go to school? Both undergrad and high school.
Wow.
That's a thin one.
Oh, there's my, I have a butterfly upside down. I don't know if it's backwards because it's a symmetric object.
Yes.
But we could measure the focal length if I had a third hand.
Right, the hand in front of me.
Let's see. Ooh, wow. Oh, wow. That's quite a bit better, but you're right, the depth of field is a lot worse on the thick lens.
And it's upside down.
And it's also upside down, yep. And thick lens has a much shorter focal length. So there you go.
About 77 centimeters-ish.
I think this one. There's my, there's my little... Yeah.
Oh, that's nice.
Yep.
Depth of field is much better.
Now I've got it figured out. Yeah.
About 20 centimeters.
Up there. Oh no, person.
Yeah.
Ah.
Can the person who's sitting facing us? Yeah.
There's our upside down butterfly. And the focal length. 19 centimeters. Okay. So, yeah, good to see you.
We ask each researcher to do it about once a month. And so Jillian has done it about 6 times with us so far. We've had about 25 of them so far. We have another one tomorrow, like at the museum. We started back in March.
Since I'm in Washington, I try to do them in person when I can.
Which is great.
Yeah, which is good.
Definitely not the focus.
So if you're in the DC area, how often does this go on?
Usually about 4 or 5 times a month.
Wow,
I'm trying to expand it. So I'm hoping to get up to the point where we have about 8 a month.
Cool.
That one? Okay. So this one is meteorite or meteorong Chinese space rock. First
Okay.
of all, rocks from outer space have to come through our atmosphere.
Yeah.
So they have to be pretty strong. So rocks that have lots of holes in them are not usually from outer space. So if you take a look at all these rocks, some of them are going to have holes, and those would not be the ones. Sorry, this is.
Oh, this is this? I don't know what has holes. Oh, this one has holes. Yeah.
It's got a lot of holes in it.
Yeah.
This
This
is
is like
lava rock, actually.
igneous. Yeah.
Exactly.
All right. So that's Earth rock.
Earth rock.
Gotcha.
Okay, so we can start there. So they're also, when they come through the atmosphere, they get this dark crust on them.
Yeah.
So anything that's light in color is probably not.
Okay. So I would say that's pretty light in color. That's some kind of chalky
Yeah,
Not sure what that
it's
is.
a quartz.
I used to be better at this, and I don't suppose this came through the atmosphere as well.
No,
It's too shiny.
Far too shiny. So our next clue comes because meteorites come from the asteroid belt.
Yes.
So there's two different kinds, mainly two different kinds of meteorites: stony meteorites and iron meteorites.
Yeah.
So both of these, let's see. The stony meteorites come from small asteroids that never differentiate. So with really big asteroids, the iron falls to the center and forms a core. And so you've got a crust and a mantle and a core like Earth does. But stony meteorites come from small bodies that never get big enough to have a core. So this is going to give us some more clues.
Sure.
Both of these have metal in them. In our solar system, the asteroid belt and all the planets do have lots of metal in them. And metal is heavy. So meteorites are heavy.
Okay.
This is an easy way of explaining it. So remove any lightweight rocks. Those are going to tend to be Earth rocks.
This feels, I don't know. What's really light? I don't know. I guess this one's really light.
That one's pretty light.
What is that? Is that a fossil? Okay.
It's a turtle scoot.
Oh, okay. So yeah. There's no space turtles yet.
No space turtles. Not sure.
Yeah.
No real space turtles.
Okay.
So now we're gonna be forced to use tools.
Woohoo!
It's not just any metal in there, it's actually iron.
Yeah.
Meteorites have iron in them. And what attracts, is attracted by iron?
Magnets!
Yes, that's a magnet.
All right,
So see if any of those...
Yep.
Okay, all right.
Ah! No, okay.
Okay,
So
that's
these are magnetic.
definitely attracted to magnets.
Yeah.
All right, so we can put those in the maybe think those, they
think
fit
these
all
are
the
meteorite? Okay.
criteria. And how about these over here?
Oh, gosh. Is there
This
any...
one's-
Is there like a tiny bit, maybe?
This one just attracted a tiny bit.
Oh.
You have to be a really special detective to find that one because it's not much.
Oh, yeah. I can,
Yeah?
like, barely feel it pulling.
Yep, exactly.
And this one, nothing. A little bit. Okay.
So you did great. Very good. So
Woohoo.
first we're going to pick out the iron meteorite. That's
Yeah.
this one here. Got a picture here of the
Ooh.
biggest one in Namibia. It's
Oh,
the
yeah.
Hoba meteorite. It's the largest one ever found. And that is an iron meteorite. That comes from
Very
the
cool.
center of an old asteroid. And then we've got stony meteorites.
Hey.
This one here is
Yeah.
the stony meteorite. Now, it's not as attracted as strongly to the magnet because it doesn't have as much metal. This one's mostly just iron and nickel.
Yeah.
This one's got metal grains in it. You can see this is a piece that's been sliced open. You can see there's a
There we go. Oh,
magnifying
Thank
glass
you.
if you want that. Little chondrules in there and metal
bit.
grains.
Yeah. Oh,
Sometimes it takes a
There we
bright
go.
light to be able to see the flashy.
yeah.
This one here is a trickster. This is a lodestone.
Oh,
So this
okay.
is an earth rock.
Yeah.
And a lot of people, when they're looking for meteorites, they find lodestones or slag.
Yeah. Slag was a big one when I was in college. They'd bring it over.
There's no way to tell unless you do some further testing. Although
Yeah.
you could pretty much look at this one and
Back home,
guess
there
that
was
it's
also,
not.
Where I grew up, there was also pig iron in the river.
Yes, exactly.
It's just like really weird. Look at this. It's all smooth. It's like
It's-
metal. Yeah.
Yeah.
And it's attracted to a magnet.
Pits in it. It's
Yep.
like it totally looks like one.
Totally. There's one other special one that you
Yeah.
didn't find
Okay.
here. This is actually a tektite. And tektites occur when large impacts, large pieces of
Oh,
meteorite,
yeah.
hit the Earth, and they're so big that they create, say, an impact crater. And that crater, if it hits sand and rock, that sand and rock heat up,
Yeah.
and when you heat sand enough, it becomes glass.
Yeah.
So
Yeah.
this is a piece of glass that's been spewed out from an impact. So it's not from outer space, but it's been to outer space. It's probably
So what is
most likely been.
This is the notch.
I know. Well,
Or just put it on the border, right?
It's actually an earth rock.
And that's an earth rock. Yeah.
You know, it's asking. I'm like, I don't
Oh
know.
no! So there are other types of meteorites too that
Yeah.
aren't shown here, but these are the two most common. I think
Sure.
they make up 90-some% of everything you'll find. And if you're going looking for meteorites, a stream bed is not the place.
No. Yeah. That would be a
Very hard
little.
to tell. There are two meteorites in
Yeah.
there, but I think it's this one and
Oh, wow.
this one here. There's a little key right there.
Oh,
Those two are actually meteorites, but you would never know because there's so many rocks. If you want to go looking for meteorites, you want to go to a glacier or a desert or somewhere that's got no other rocks around.
Right.
A really cloud field is actually.
Antarctica is a great place, of course.
Yeah.
So how does someone get their hands on a kit like this?
So these kits are designed for amateur astronomers. They're designed to be very simple to use at outreach events or at the telescope, depending. A lot of them have observing cards that come with them that talk about what you can see at the telescope that relates to this.
They usually ship them with whenever the clubs that are members of the Night Sky Network, when they register a couple of events that I do in the public. And so then we'll ship them out.
Okay.
We always get feedback and everything.
Yeah,
We're always updating them too. And there's also on the Night Sky Network homepage, we also have the resources page. And you can actually, everything that's here, you can
download it.
Pretty much, you can't download the meteors, but you can, you get like the actual
that would be cool.
And like the maps and all the other stuff. And like everything we get for the most part is like something you can like get at Michael's or a scientific hobby store.
Right. So you can put it together yourself.
Especially because it's sort of like, it goes out to the field, oh, it breaks, just, okay, it's like $1 to fix. Or it's in like your junk drawer.
Yeah, awesome.
So the Night Sky Network is a group of over 425 astronomy clubs. They get these kits for free. We have 11 of them, ranging from supernova to solar system.
Solar planet.
And there are more coming out all the time. We have 2 in the works right now.
Oh, cool.
So,
very cool. Excellent.
A lot of good outreach. A lot of them will have like observing sheets. Show. This one's got Galileo's observations and a place for them to show and what you might expect to see in a telescope.
Cool.
Cool. Lots and lots of activities. Dozens, I guess.
Thank you. Cool.
Yeah.
So we're going to find the focal length to a distant object. Yes. Okay. So we don't have a lens holder, but we do. Oh, there's my. I have a butterfly upside down. I don't know if it's backwards because it's a symmetric object. But we could measure the focal length if I had a third hand. Thick one. Can I try that?
Thick one. They're all different. Oh wait, that looks like 2.
Yeah, that one's got.
That's a double. It's already been put together.
Yeah. Here we go. No.
Try to get out.
And then you have these little
2 lenses. We have a thick lens and a thin lens.
Ah, I see.
So here's the thick one.
Okay.
Here's the thin one.
All right.
Oh yeah, okay, yeah. You can see.
So I think I'm holding the thin one.
Yeah. Here's a thick one. I don't know if we can share these around.
Sure. Oh, there's. Oh, there's our light source. And here's our screen. You should be able to see on either side.
Where did you go to school? Both undergrad and high school.
Wow.
That's a thin one.